Many students have a hard time understanding the difference between a subset and a proper subset. So I thought I would take a minute and go through it just to see if I can explain it a little better. So first of all, subset is denoted with the symbol that looks like a C with a line under it. Proper subset is just a C on its own. And the difference, the way I like to think about the difference, is the same as the difference sort of between less than or equal to versus less than, right? So I'm going to put that over here on the side. We know, for example, that if x is less than or equal to 2, that means that x can be any number up to and including 2, right? It can be 0, -1, 1, but it can also be the number 2. On the other hand, if we have x is strictly less than 2, that means that x can be 1.99999, but x can't actually be the number 2. So let's take that a concept and let's apply that to our sets, to our subsets. So for example, if we have A is a subset of B, that means by definition that every element in A is an element in B. Visually, what that looks like is if this is B, then A is a circle within B. But it's also possible that if this is B, then A is the exact same circle as B, and they might actually equal each other, because then every element in A is an element in B, and it fits in with our definition. Now, if we look at a proper subset, and we have A is a proper subset of B, that means, similarly, every element in A is an element in B, but also A cannot equal B. So what that means is, again, we have our circle that is B, but that A has to be strictly inside of B. We do not have the possibility that A can actually equal B. So again, a subset means every element in A is in B, and A possibly could be the same set as B. But for a proper subset, it means that A has to be strictly smaller than B, meaning if we create a circle, A must be a circle smaller than our circle B, and they cannot equal each other. Two things that are important to note. The first one of which is that A is always a subset of itself, because every element in A is an element in A, but A can never be a proper subset of itself. That makes no sense, because A actually equals A, and that contradicts the definition of what a proper subset is. The other thing to take note of, so that's the first thing to take note of. The second thing to take note of is that the empty set, or the null set, is a subset of any set that you might have, because you can always create the empty set, and its elements clearly will be in whatever set you have.